Yes, we are live now.
Okay, just share the link and someone just check the audio, okay?
And we'll wait for 5 minutes. Right?
Yes, we are live now.
Okay, just share the link and someone just check. Okay, great. Someone please check the audio.
Pardon?
Sir, no, not to you. So anyone other than this, you can just check the audio, yeah.
Audio we can hear. The sound is coming.
Through the live stream?
Yes, the YouTube is coming.
Okay, great. Everything is working fine. So I
Okay,
think
audio is working fine.
yeah, we can
It's
actually.
clear
I
from
think
all the sides.
I think we are public. Yeah, that is totally fine. Yeah, I think we can like we will wait for 5 more minutes, I guess, and then we can start the thing.
Yeah.
Yeah.
I will start sharp at 7, okay?
Okay, sure, no problem.
Yeah.
Okay, and Diksha, you'll tell me when to start, right?
Yes, sir.
Okay. Diksha, you'll tell me when to start.
Subrata, you should. Okay, no problem. Subrata, can you close the WhatsApp tab?
Sure. Is it fine now? Can you check?
Can you close the?
Okay, it's fine.
Otherwise, if
the
anyone is
list
having
of
some,
services.
if the volume is up on other device, just mute it down for the YouTube.
क्या?
YouTube में अगर तेरा साउंड ज़्यादा है तो just mute it down क्योंकि reverse feedback आ रहा है इसे on the
तो अपने आप को म्यूट कर एक बार.
okay, just check once.
Sir, am I audible to you now?
Yeah, very much.
Okay.
Subrata, you have sent me the link?
Yes, sir. Just hold on a second. I'm just actually putting on.
Oh, okay, sure.
Yes, sure.
I thought there's something wrong with my network. No problem.
No.
Subrata, তুমি ফুল স্ক্রিন করে দিবা হ্যাঁ স্টার্ট হওয়ার লগে
Full screen में option तो अच्छा.
ডাবল ক্লিক করলে ফুল স্ক্রিন হয়ে যাবে
Yeah. Just Diksha, unmute yourself when you want to speak.
Yeah?
Just unmute yourself. No, you're fine.
Yeah.
Minutes, I guess, and then you can start.
30 seconds.
And so we can start at 7. Yeah.
Okay.
Okay. Hello audience, this is day 2 and welcome to another Tech Talk of DSC Explore. I am Diksha and today I have with us Mr. Mohammad Azharuddin Lashkar. Sir has done his degree in BTech in ECE from Northeastern Institute of Science and Technology in Arunachal Pradesh. He also did his MTech in Electronic Design and Technology from Tezpur University. He completed his PhD degree in the Department of ECE from NIT Silchar this year. He has a large experience in teaching and R&D. He worked as a guest lecturer in Northeastern Institute of Science and Technology, Arunachal Pradesh. He was a project engineer in Department of ECE NIT Silchar for a project sponsored by the Government of India during 2014 to 15. Currently, he is working as a data scientist in Arm Softech Private Limited, and his area of work is primarily speaker and language recognition. He has published several essay journals and conference papers in the field of speech processing and machine learning. Sir, on behalf of DSC Explore, I welcome you.
Thank you so much, Diksha. And I would like to thank DSC Explorer for inviting me for this talk. It's an honor, and I'm so pleased to be able to contribute in some way or the other. So,
thank you so much, sir. So moving ahead in the session, the very first question that I would like to ask you is,
Diksha, I think I just lost your connection.
okay, no issues, sir.
Okay. If you could repeat, yeah.
Yeah. So the very first question is, what is artificial intelligence?
Okay. So I can start my answer.
Yeah.
Yes. Okay. So thank you. Artificial intelligence, like it's a kind of word we happen to use so much these days. So let me explain this word with the help of this slide. You see, like anything that you make a machine do, which otherwise you would do yourself using your own intelligence, is artificial intelligence in a broad sense. However, in today's term, when we take the term AI, we more or less refer to it as a kind of algorithm, as a kind of mechanism which has the ability to learn by itself. So, you see, we can divide AI methods into two groups, like logical and rule-based. The other is machine learning-based. In logical, it can be said that we have a kind of program which we have written in our hard disk, which uses some if and then else kind of algorithm and has a set of knowledge inbuilt there. And when we use it for certain kind of applications, it gives us very intelligent kind of responses. Whereas the other category is machine learning, and which suits the present definition more correctly. This algorithm has the capacity to learn by itself, like it has a self-learning capacity, so to say. So it learns from the data, and it builds in the intelligence in itself, and then responds just like the way a human would do. So this is what artificial intelligence like in a broad sense. Yes.
Yeah. So, sir, I would like to ask you another question. What will be your tip or suggestion for someone who wants to start working in the field of artificial intelligence?
Okay, like you see, artificial intelligence covers a very wide kind of area. Like it's being used in diverse areas these days. So, like whoever is trying to solve a problem, be it in medical or biology or physics, I mean, they can actually explore it in their own field itself. They did not come up and like take up some problems which are very much highlighted or very much in talks these days. So what can be done, like if someone has a problem in biology or something to do with DNA, someone has a problem in chemistry, so something to do with getting the right combination of chemicals, this and that. So they can all be using the AI methods. So AI methods are in general applicable to all sort of problems. So the first and foremost thing is that you develop some kind of interest. You start with something very simple. Like there are a lot of materials that we find these days over the net. So these materials are mostly available free of cost. There are also some courses that you can find in Coursera and Udemy kind of platform. This to help you to just get started in a very fast manner. But the basic thing is that you try to develop some interest in it. So for that, like you start with something very simple. Like you try to find a problem which you are really related to and you can connect to, and then you try to find ways that you can solve that problem. And as you go on solving that problem, you come across many AI methods, many algorithms, and that you can pick up over the period of time. So I would just suggest that if someone is interested in exploring AI, he or she should try to find out some problems which he would like to solve. I mean, it can be some problems which are already defined over the internet or any of the places. You have so many competitions these days over Keras, and also you can actually go and pick up some of the problems and then try to find out which algorithms would be best suited to. So you can pick up those and start working with it. The best way is like learning by doing, like as they say. And there's so much of algorithms, so much of platforms to choose from. So it is best you try and choose a platform which you find easy to work with. So these days, like we have something like PyTorch and Keras and TensorFlow. All of those platforms like have their pros and cons. They are all good enough to actually deploy certain models uh, even at industry level. So you can pick up one of those and just start trying to solve problem which is very related to you. So once you develop that kind of interest, you see your your problems getting solved as you go along, exploring newer and newer algorithms. You in the process you get to learn a lot of AI, and in a matter of time you'll be in a position where you can actually suggest the kind of algorithms to be used given a particular problem. So this is what I would like to say. Like this is the approach that one might take when starting with AI.
Yeah, we have problems around us. We just need to pick up the problem and start working on it. And as you have said, there are resources online available. So you just have to have the zeal to start working, and then you can just follow, right?
Exactly.
Yeah, so sir, moving ahead, as I've also said in your introduction that you are extensively into R&D also. So I would like to ask you about your research work.
Yeah. Research, like basically I've been working with voice biometry. Voice biometry is like speaker recognition. So the task is like these days we have a lot of ways of authentication. We heard about fingerprint, we have heard about iris scanner. So and similarly there are other, like there's face recognition. You also have it these days in your mobile phones. So similarly we can actually recognize and authenticate people using their voices. This gives us a lot of advantages in the sense that like you do not need an extra kind of device to actually implement your system. Why? Because you can be using your very own phone to talk to the system, and so that system, it could be a server which is remotely located. You don't have to be in present right before the device as it is in the case of fingerprint or face recognition. So like something which can be done very remotely, this is a huge advantage. That means like you can do some authentication right from your home, or be you need not be at the place or near the server where you are getting authenticated. So these days these things are very much applicable in banking systems. So and voice is something like which is so natural. You see, it's the most natural way of communication. So and every individual is supposed to have a very unique kind of voice. And of course, some people might be having voices which closely match each other. But if we have a better algorithms, we can always differentiate between the two. So, given that advantage, given the cost effectiveness, voice biometry is is a very hot topic among the researchers these days, and it has got numerous applications like across industries and enterprises, where you will find people having a group of employees around 100 in number, and they want to authenticate people, like if they are going for any particular kind of transactions or not. So this is what, and my area of research was more focused on text dependent speaker verification. You see, like voice biometry can be done using some password kind of stuff, or it could be done by speaking any random words. So it has got two classes basically: text dependent and text independent. So if you are free to use any kind of sentences at any point of time, then that system is said to be text independent. And when you are actually allowed to just pick a particular sentence which is already known to the system, that particular method is known to be text dependent. And as you can understand, if system already knows the kind of passphrase, the password you're supposed to speak, then it becomes much easier for the system to actually authenticate you. So the accuracy that you'll get in text independent speaker verification is much better as compared to that in text independent speaker verification. However, you have more flexibility when it comes to text independent speaker verification. So my work basically was related to using machine learning algorithms and deep learning algorithms to enhance the performance in text dependent speaker verification system these days. So maybe I can take you through a little. Okay, like just to help you people appreciate the the role of AI in the field of speaker recognition. You see, like one of the most common and the most important features that we use in any of the speech application is MFCC. This is, like any machine learning algorithm, any deep learning algorithm, we always start with a like two-stage thing. Like we have features to start with, and then we model the features to obtain our goal. So this is MFCC. I'll just like to take you through these steps. It has got nothing to do with AI, but this will help us to understand the role of AI in speaker in any of the speech applications. You see, we start with SM stands for the speech signal. So this is a speech signal. It goes through a algorithm, a signal processing algorithm called FFT, fast Fourier transform, and it gives you a frequency spectrum. And you see the frequency spectrum, like it's a continuous kind of spectrum. But you see, our human here does not really like recognize each and every frequency that well. So it hasn't got that much of a resolution. So we use kind of filter banks which help us concentrate more on frequencies which are more useful. So you see, like we are using a kind of filter banks there. There are m number of filters in that filter bank, and we try to these are all bandpass filters. So we try to extract some average of the power spectrum over there, and then we pass it to a log block. Why I tell you log? Because our human here is like not response. It doesn't have a very linear response. Like if someone shouts at 10 decibel and then shouts at 20 decibel, okay, and then again shouts at 30 decibel, the difference that the human here makes out from 10 to 20 isn't the same as the impact when it hears from 20 to 30. So it is not linear. So this is somewhat logarithmic, and which is why like we take the logarithm of this filter bank's energies and again take a DCT. DCT is taken to decorrelate. Now, why I tell you this? Before these things were implemented, a lot of thought process went on as to how can we featureize the speech signal. You see, started with converting it into frequency spectrum, and then from frequency, like you see, many of the filter banks used to get selective kind of energies, and then we pass it through a logarithmic block, and then we again pass it to a discrete cosine transform operation. So ultimately we get MFCCs, and we can somehow make a distinction between different speech signals or different speech sounds. But what happens, I'll show you in the next slide. You see, this is it's like jumping to a very complicated kind of network. But my point here is to like help us appreciate what the DNN is capable of. You see, so much of thought process was put in before we actually derived the features called MFCCs, which is male frequency capture coefficient. Now here you see, this is a SyncNet network which was proposed in 2018. Except for the speech signal, there is no signal processing. There is no explicit signal processing steps required here. You see, the speech signal directly goes on to neural network. The SyncNet filters are nothing but they can be implemented using neural network itself. So you see, there is a number of layers of sync filters, each having different frequencies, and these frequencies will keep on changing as we go on training the network. I'm not trying to make you understand the different layers and how the different layers function, just to help us appreciate why how this particular kind of neural network helps us obtain the kind of features that we look for. You see, we do not have to go for handcrafted features anymore. we may not use MFCCs anymore if this kind of neural network helps us to generate its own features. It helps us generate its own features depending on the application, and that helps us get better performance. Suppose MFCCs, just to make a point, MFCCs have been used across all speech applications, be it speaker recognition, be it speech recognition, be it language recognition. But you see that this is not specific to any kind of particular application. But we all know that we are when we target a particular application, we actually target a particular characteristic of the signal. We do not use all the information across the signal. So you see, but MFCCs is like constant. It will have the same kind of information, and we got to train it further and model it further to help us implement the kind of application that we intend to. So here in this case, if we have speaker classification problem in your hand, what you can do is you can train the neural network to classify speakers. And in the meanwhile, what happens is you need not give MFCCs. When you give MFCCs, there are so much of signal processing steps which go on, and then like you tend to lose some of the information which otherwise could have been helpful to your case. So the neural network decides which is helpful, which is not, all by itself through its learning algorithm, and keeps the most relevant kind of information in it, and gives us much better kind of result. If I go ahead, to talk a little more about my research, Diksha, I think I can just go through quickly about the research that I actually do. Yes, Diksha, am I audible?
Yes, sir. Yes, sir.
Okay. So you see, this is machine learning based speaker modeling. So if you have voice biometry as a problem, you can start with one of the most basic models that is used that are used today is like Gaussian mixer model. You see, like there's a diagram at the bottom which actually gives an idea how a Gaussian mixer model looks like. In short, we call it GMM. So this has been very successful. Like when it comes to speaker modeling, you can have data from speakers. By data, I mean you have some speech utterances from the speakers, and then you can actually make a model using Gaussian mixture model algorithm. This is a generative kind of algorithm which helps you to parameterize all the information that may be available in that speech utterance. And so for every speaker, you can go on making a like GMM model, and then when you want to implement a system, suppose you want to go for a speaker verification system, you can keep those templates, those GMM speaker models templates in your hard disk, and then you can get a new test utterance or verification utterance from the speaker and compare with each of these models. And when you compare with these models, you can get a score, and depending on the score, you can find out which speaker would more likely is closest to that particular utterance, and you can that way verify if that particular speaker which is claiming a particular template ID is actually matching the template that he is claiming about. So that way, this speaker verification problem can be tackled. So GMM was one of the initial machine learning technique that was used for solving this problem. So then came this eigenvoice technique, which we also explored. You see, in eigenvoice, machine learning in GMM, what happens? There's a lot of data which is required. So it might so happen that in many of the situations, you might not have so much of data to actually make or build a GMM specific to any speaker. So in many of the small enterprises, you do not want people to be standing for 2-3 minutes altogether and speak to the system. It would be very, it will be troublesome, and it will be a nuisance. So what they do is like to be able to enroll a particular speaker or register a particular speaker, we can actually use a different technique called eigenvoice technique and do the same job using lesser amount of data. I mean, lesser number of speech frames. So what they do is like they start with a training set. In the training set, we have a lot of speakers, and each of the speaker will have a uh, lot of utterances. So we make GMM with respect to all those speakers. Once we have the GMM with respect to all the speakers, then we can concatenate the means of all the Gaussians in the GMM. I mean, like a GMM is a mixture model, so it has got a lot of Gaussian models in it. So we can actually concatenate the means of each of those Gaussian, and then we'll have a super vector. And this super vector corresponding to each of the speaker can be all put together in a matrix, and then we can go for some of the techniques like principal component analysis. These are subspace techniques. So you create a subspace which is like which can actually accommodate most of the speakers. Suppose you create a subspace using 1,000 speakers, then you can assume that most of the new speakers would also be uniquely represented in that space. So that was the technique used. So they had a training set and they build a eigenspace. They call it an eigenspace. And so every new user using very less amount of data could be actually projected in one of those point in that new subspace. And that subspace can be reversed and you can get the GMM back. Or you could also compare speakers depending on their on the location in that subspace and apply the same mechanism of comparing the scores, and you can implement this speaker verification task. Now this is after eigenvoice technique. You see like they came up with this new technique which is called joint factor analysis. This is a factor analysis technique where we assume that there could be some hidden dimensions, there could be some hidden directions which actually encode most of the speaker information. So if you have a lot of data, we can, this is a common subspace technique, a factor analysis technique. So it's nothing very new to speaker verification or speech application as such. So when we have a lot of data and we assume that there are some specific directions which you want to exploit, and so we can actually use the data to train a factor analysis model, and this will give us some factors. These factors are actually our speaker information or channel information, and as you can understand, this will help us implement the same thing using much lesser number of data. So I'll not go so much into the details and the mathematics of it, I mean, which is not required. I just wanted you people to have a intuition as to how these things move forward, and ultimately we came across using more and more of DNN and AI stuff. Now, on similar lines, we have I-vector PLD system. Again, it depends on the subspace technique. And one thing you have to notice, like they always use MSPCs to build the GMM, and using the GMM, they're going to make a subspace. In this case, it is I-vector subspace, and then on this subspace, they project the new speaker and compare the scores to implement either speaker verification or speaker identification. Now, see, then came this deep neural network. So in deep neural network, you see, these are the things that I explored during my PhD work. So in deep neural network, what they're using most of the training data set to build a kind of network to actually classify those speakers in the data set itself. Okay, suppose you have 100 speakers data set. 100 speakers data set is a little too small, maybe 1,000 speakers data set, and you classify those speakers using a DNN. I mean, before you classify, you're supposed to extract some features, which is mostly MFCCs in this case, and which is stacked up, and then this MFCCs are put onto this at the input of the DNN. And as you can see, there's something called bottleneck layer, which has lesser number of nodes. And then we have the output, something which is labeled as posteriors. This actually represents the different speakers' output node. So you see, like there's the 1,000 speakers in your training set, you might have 1,000 output nodes. But you see, like this would not solve your problem because you don't want a system which only caters to 1,000 speakers. I mean, if you have a new speaker to add, you cannot be using this network anymore as such. So what is the way out is, like instead of depending on this output nodes, what they take is they take the bottleneck features, which is highlighted with the level bottleneck, they take the features out of it. They take whatever values come out at those nodes, they extract that and they form a feature vector out of it. And this feature vector can be further modeled. Instead of using MFCCs, you have a new feature which is bottleneck feature, which is obtained using DNN network. Okay, a deep neural network. So these features happen to complement the MFCCs in a very in a very effective way, and then it helps us improve the performance, be it GMM model, be it iVector model, be it JFA model, all that we had just seen a little while ago. Now, on similar lines, we have tandem feature. Tandem feature is when you combine the MSCC feature, which is your handcrafted features, and the features which you obtain through neural network, deep neural network. If you combine these two and build your classical classifier like GMM UBM system, this is known to be your tandem feature. Now, this is something I did during my PhD work. I published this paper in speech communication under Elsevier Publication House. So you see, like what we did is like we had a training set and we are supposed to train a DNN. So as I told you, our task was basically text dependent speaker verification. Here we had the task of differentiating the text, and at the same time we had to differentiate the speakers. So that way it became multitasking. I mean, both the text and the speaker had to be discriminated. Now the point is like there may be one speaker will have an utterance of 4 seconds, 5 seconds, 6 seconds, and that will how your utterance duration will be in the training set. So if you level that whole utterance as a single class, as though it came from a single speaker and a single piece of text, so it might not really catch the intricacies and the specific text material in it. Suppose if you have a sentence, a 4-second, 5-second sentence, and if you level with a single text level, it won't serve the purpose because there will be a lot of words in it, a lot of phonemes in it. So what we did is like we tried to align the data. By alignment, I simply mean like we tried to level the data in a different way. Instead of using the whole text, whole utterance as one single class of text and speaker, we divided the sentence into different segments so that each of the segment will have a unique text characteristic. And it is observed that, I mean, when we people, when we speak different words, we can actually differentiate depending on the way we speak. Different people speak different words. I mean, if I speak a word cat in a particular way, the other person may not speak in that particular fashion. I myself may speak different words in different fashion. So it is important to catch those features and those and capture those information in a model so that like we can actually increase the performance of our speaker verification system. So what we did, we used a HMM based model, which is here it is called HILAM model. An HMM based model would simply segment your sentence into different states or different divisions, and then and each of those divisions or each of those states or segments will have their unique characteristics, and they will be joined by some transition probabilities or observation probabilities. I mean, those mathematics, it's good enough if you get the intuition that like an HMM model can actually model the utterance, and based on that you can differentiate one utterance from the other. Yeah. So HMM model does that. So once HMM model also does one thing is that it considers sentence as though it is made up of a number of segments, and which is technically known as state in its case. So each of the states will be actually representing a certain text or a certain speaker characteristic. So what we did is like we considered a particular state to be a particular class, and this is otherwise. So far, what was happening is that we used to average out everything. Like we take the whole sentence and give it a particular text level, and the information somehow gets averaged out and lost. And what we did is like we took a particular state and we leveled it accordingly. So we had a lot of states from a single sentence, and we train our DNN in such a way that it perform a multitask kind of uh, operation, and after that we did the normal thing. Instead of we just discarded the last output layer because we are not interested in just recognizing our training class speakers, and we took the embeddings or the features from the second last layer and we use it for further purposes. Here is a backend and all. I'm not going into details of this. So these are the different. Once you get the deep features out of your DNN network, you can have a lot of other backend classifiers like DSA classifier, LDA classifier, or you could also go for like DTW matching, dynamic time working matching. Those are different techniques you can use once you get a good discriminative feature, as it is in case of deep learning, deep neural networks. Yeah, Disha, like this is what I basically did, and I also use X vector in my research. X vector is kind of a latest kind of a DNN network which was proposed sometime in 2018. So this is a neural network. You see, it is actually known as a time delay neural network. So I think like giving an intuition at this point would be good enough.
Yeah.
Okay, Disha.
Yeah, so as you were taking us through your research project, there were some questions from our audience. Abhishek
Okay.
was asking you to also explain a bit about AGI.
Pardon?
Abhishek Chaudhary was also asking you to, explain about a bit of AGI.
AGI, I didn't get that word.
Sir, that is
AGI.
artificial general intelligence. Actually.
Please come once again.
So that is artificial general intelligence. That is they were asking about.
Oh, I think I don't understand the question properly. Maybe something which I missed out. Like my apologies. Yeah.
They just asked to, elaborate a bit about AGI.
Was it somewhere in my slide?
No, I think they got a bit curious about it.
Okay, I'm so sorry, Abhishek. I just think I'm not in a position to explain that.
Okay. We also have another question about logistic regression. They're asking you to explain a bit about logistic regression.
Yeah, logistic regression. You see, logistic regression. Why is it called logistic regression in the first place? Because we heard about linear regression, right? In linear regression, we have a line-like model, just a line-like equation, just the one that we had for straight lines probably. So that is linear regression. And in linear regression, basically, if you have certain variables dependent on one variable, so if you have certain variable dependent on a number of variables, you can actually train the coefficients over there. So that is good enough for regression. That means like you have a certain set of variables and you want to particularly find out the value of the dependent variable. Now when you want to use it for classification, so most of the time our classification could be binary classification or could be multi-class classification. You see, so this particular linear regression may actually be used in a smart way to actually help us also classify things. And here logistic regression come into play. So logistic regression, you see, it's regression in the first place, and then we have a sigmoid function. Now, if you use the value of the linear equation, the summation that we have of suppose y is equal to summation of a number of ai, which will vary over the range of equal to the number of variables that you have. So if you give that summation to a logistic regression, I mean a sigmoid function. So that sigmoid function will give a value between 0 and 1. So instead of giving you a real value, a number which is spanned across a whole range, you have a value which is spanning across 0 to 1. So if something is closer to 0, and the sigmoid function, if you ever look at it, it comes in an S-shaped form. Okay, so if you have something which is more towards the positive side, you'll get a 1. If you have something towards the negative side, by negative I mean if you have a lesser value of that final dependent variable that you get, and you get something very close to 0. So this sigmoid function, when you apply over linear regression, helps you to classify a particular like a variable or vector, whatever a feature that you have in hand, into one class or the other, the 0 class or the 1 class. So this logistic regression may also be used for multi-class classification, because here you see it's a binary thing. It gives you either 0 and 1. So one of the very intuitive way of doing is, like, suppose you have 10 classes. Now how do you go about using logistic regression? So what you can do is, like, you can keep one of those classes as intact and then merge the rest of the classes. So your problem again becomes a binary classification. And then you can repeat the same thing with each of the classes. That means you take one class as intact and merge the rest of the classes and again make it a binary classification problem. And that way we can use logistic regression to actually solve our problems of binary classification. So just to summarize, like, you have it's important to understand that it is regression in the first place, and then we have used this logistic sigmoid function over it, and which is why we name it logistic regression. In real sense, it is not regression; it is classification rather. So that is where it came from. I hope, like, I was able to answer it to some extent.
Okay. So, sir, we also have another question from Mr. Rajat Kanti Bhattacharjee. He was asking, wouldn't the eigenspace require the data of have massive variety? Because the eigenspace will change for every new data. It's like more data is equal to better eigens.
Okay. So you see, like, when I talked about using GMM, if you are to make a GMM model, it will require a lot of data. I mean, if you have to have a very good performance, but no, it may not be very much applicable in real-time scenario when you have to do it for some kind of enterprise and all. But when it comes to eigenspace, as you rightly pointed out, we do need a lot of data in the sense by training it. Suppose, but you see, if you talk about offline data, we can get a lot of data. Suppose 1,200, 1,000, 2,000, 3,000 speakers data, each having a number of numerous utterances across different channels, situations, background noises, and so we can have those data intact. And it is a one-time training process. So once we have that data, we build the GMM models, and from the super vectors, we can have a super vector model corresponding to each of the training set speaker, and then we can actually perform PC and get the eigenspace. Once we get the eigenspace, you see, like, it's not very important that we this eigenspace will be having will be actually a common, a general space for all the people. I mean, each one of us more or less will have a unique representation in that eigenspace. So you see, like, if using a less number of data and an algorithm that we have, MLED, these are eigenspace decomposition algorithm. Using that algorithm, we can actually find a point in that eigenspace, which is much lesser amount of data, and then, like, represent it in a unique fashion. And actually, it is reversible in the sense that from there we can also get our GMM. What would be the most likely GMM super vector from there? So this is how it is useful eigenspace thing. I'm not sure if I really answered the question you asked.
Okay. So we have another question from Mr. Soumya Ranjan Mohapatro. He was asking, what effect would noise have if it were present in the test samples? And for removing the noise, what method would one prefer?
Okay. What he asked is, like, if there's noise in the test sample. So the first question is, like, obviously, when you train a model for any application, you have to take care of all these different situations. There could be noise, there could be, like, half data. Sometimes there could be, like, break in the communication, and you're left with very little utterances. So you'll have to prepare for all the situations. And you see, the whole idea of making a robust model is to make it such that it does not get affected by any unwanted kind of variabilities. So when we suppose, for example, we just talked about eigenspace. When we build the eigenspace, when we do PCA, we make sure that we actually try to find the directions which are more important for speaker discrimination, and we try to mitigate or discard the direction or variabilities which are due to noise and all. So even if you have a test data which is full of noise, the moment you use that model and project it in a different subspace, because the direction for noise has already been thrown out, only the speaker discriminating part will be actually reflected in that new eigenspace. Okay, this is how, like, obviously, it depends on what extent you have trained your model. I mean, how good your model is. So if you have really noisy data, sometimes it might even fail. I mean, which happens very often. But like if you have a very robust system where you have a training set if your training set is full of data which have all the different sort of noises, it becomes much easier to train and space an eigenspace space which will be actually able to mitigate most of the noises. Okay, so if you're worried about your test sample having noise, then stop worrying about the test sample having noise. Stop worrying, like you should start worrying about the kind of noises that you can incorporate in your training set. So you do some augmentation in the training. If you have a training set, you can augment it. I mean, by augmentation, I mean you can add some kind of noises to it, which you think you might come across in real scenario, and use that data to train your model. And your model will learn by itself, because it is all self-learning. It will learn by itself to actually discard the noise part and take only the part which is useful for the application. And the second part was, could you just repeat the second question?
Yes, sir. He asked, and for reducing or removing the noise, what method would one prefer?
Okay. As I like the half part is answered already, because you may not be able, you may not really bother about removing the noise because the model might take care of it. The other way is like speech enhancement. I mean, this is always helpful. But when you go to, there are so many speech enhancement techniques available today. But like, it is not preferable that you should go for speech enhancement if you have an application which is to do with language identification, or you have to go for speaker identification. Because you see, speech enhancement will help you to actually have a cleaner speech only with respect to how it is sounding. I mean, how the words are sounding. In the process, you might actually lose some information which could be important for speaker recognition or could be important for language recognition. So as such, any artificial or handcrafted kind of enhancement technique, it's not preferable. So the best thing to do, or the option that is left to us, is to train our model in a very robust fashion so that it can actually handle all the different sort of noises. And there could be techniques which help us reduce the noise and like have a cleaner speech, but it is not recommended in this kind of applications. Hope I answered the question.
Yeah, so these were some questions that were posted by our viewers. So moving ahead, sir, I would like to ask you, what is the roadmap for a research work?
Okay, roadmap for research work. You see, like as I told you before, like the first thing is you try to develop some interest. Find a problem which you can relate to. Otherwise, like reading a lot of papers become very boring if you just have to do for the sake of research. So you have to kind of develop a kind of interest in a particular topic, and then you yourself be driven into studying. I mean, the best way to do it, like you study some good basic research papers, and the other best thing which is is that today, if you want to implement something, most of the time you find some help from internet itself. Like you have ready-made codes to start with. I mean, there are very complex, very difficult to program kind of codes which are open sourced. I mean, by many researchers. Those can be used to kickstart your research in any case. You don't have to bother about implementation so much. And you should not wait to learn something. You should not wait to learn a tool like TensorFlow. You should not wait to learn any of the programming languages. You should start studying, and as you start studying the research papers, you can actually pick up some of the research which is like over the period of last 2-3 years, and you'll get to know what are the latest things happening. Once you get the latest things happening, you get the feel of it. And as you go on reading more and more, slowly you'll see that you can actually figure out what are the things that you can do to help improve the performance of all those proposed systems. So these two things should go on parallelly. The one thing is that you have to read those papers, and then you can take help from open source materials and try to implement many of the research that are available today. Most of them, most of those research are actually available over the internet. You can just download it. GitHub is one common source thing where you'll find most of the codes, and you can straight away start implementing. And the other thing is like these days, if you want to do something very different, and which is actually put you in a very good position, you have to start thinking about creating a database. Sometimes you have readily available database over the internet, and depending on the kind of problem you're targeting. But as I told you, like you might actually relate to a kind of problem which may not have a ready-made database. So you have to start thinking about preparing a database, and there's some hard work to be done. I mean, when you are in colleges and in universities, you have friends from where you can collect some bit of data and start actually experimenting with your artificial intelligence models. So this is what reading and at the same time implementing. And of course, it is always helpful to take up some courses like based on artificial intelligence. I'm sure like most of the you people like might even have a formal course in your colleges. So you can take up those courses. Those courses will give you the preliminaries, and like you will be knowing about most of the AI models that are available today. But you better concentrate on like the problem that you have in hand, and at the same time have a look at the latest research that people are doing. And as you go on exploring more and more those ideas and those the tweaking, or you may say the little bit of different way of doing things sometimes make a lot of difference in the performance of the system. So like this is how I think like one should approach research. I mean, just find some interest, some problem, and straight away you can start with it. Yes, Diksha. Yeah.
Yeah, so there was also this question from Kavini Suri. She has asked, the question is, does one need a master's or PhD to work in ML, or are there opportunities for bachelor degree holders too?
Very much, very much. There's opportunities for all bachelor's degrees. I mean, like MS degrees and PhD degrees. So like people are recruiting like even graduates, postgraduates, and even doctorate students for such stuff. And like there are a lot of startups like which actually look for such people. And you see, like it's quite understandable that like if you have a bachelor's degree, you may not be having so much of experience with respect to AI models. But you see, like if you have your math strong, and if you can actually do some kind of a project in AI during your BTech days as a final year project or anything of that sort, and that will keep put you in a very good position where you can actually beg a like ML engineer position in any of the companies. I mean, there's no restriction as such. Like maybe in LinkedIn and some other companies make it a must that one should have MS. Sometimes they make it a must that one should have PhD. But in many other companies, there's no restriction as far as the degree is concerned. One can actually one who's able to think about a problem in a in his own in his or her own way, and have a good way of approach towards solving it. So he or she can easily find a place. I mean, it's nothing like having a bachelor degree alone will not be sufficient. Very much. That's it. Yeah.
Yeah. So there's some questions from our audience. Moving ahead to our session, sorry. As we're talking about AI and everything, I would like to ask you how AI is helping to change the industries and how AI is implemented in it. Like as you say that many
Yeah.
AI, so I'm curious to know how it works in the industry.
Yeah, like you see, in industries like be it every industry, be it travel industry, be it the service industry, the hotel industry, be it the banking industry, they're all trying to like incorporate AI in it. I mean, just like people are trying to adopt it more and more. So you see, the very case of a speaker identification, some of the banks are already offering. Some of the banks have already offered a speaker identification. That means like remotely you can actually call the bank, and if you want to do some transactions if you want to know about your balance or any of the transactions related stuff, you can actually speak to the system, and the system doesn't ask for anything. It will just listen to your voice for a while, and then either authenticate you, or actually, if it finds that you may not actually be the real owner of that account, like the system might divert it to some customer executive. So this kind of systems are already in place these days. And how they do it's like, research actually brings it to that point. I mean, there must once if you pick up a particular topic, you see there's so much of research going on these days in AI, like across different problems. I mean, you have like something security point of view. For surveillance also, we have like from CCTV cameras. Sometimes we we install it, but we have to have a person who can constantly who has to constantly like have a watch over the screen and see if anything strange is going on. But if you have an AI system in it and who can actually detect the anomaly, there's a whole branch of study called anomaly detection. So depending on the CCTV feedback, the AI model can actually tell or like alert the people, like if it realizes that there's something which is unusual going on. So these kind of systems are also being implemented these days. And in industry, very like we may not like find it very sophisticated. Something like car parking. I mean, in some of the metro cities, like parking becomes a huge headache. So depending the AI model, sometimes what they are trying to do is like they see the CCTV feedback, or they get the images and try to get the dimensions of the car and so many other things, and they can actually create a system where they can actually direct the car where to park it, so that like the parking lot can be used in the most efficient way. So these sort of things are already happening, and as I show you in like in service industry, like you'll be often encountering IVR over and over again. Like you have voice chats to come up with. I mean, every time you'll see like when you try to speak to the customer executive, there will be an automated voice which will be speaking to you and trying to get the information out of it, and they will do some kind of NLP stuff, which is also implemented using AI. So, and they will try to understand what you want and what you don't want, and according to it, it will go on to direct you. So this all sort of service industry, travel industry, or whatever it may be, they're trying to slowly adopt this AI technology. And given the kind of research that is going these days and the kind of accuracy that are being claimed, I mean, with time to come, we might find like AI in almost every sphere of life. So even like you've heard of self-driving cars and all. So there too, like I mean, you don't need a driver to drive it. Like you have thousands and thousands hours of feedback from as a training data, and then when you train your AI model, it knows exactly how to drive the car without any human assistance. So the industries are like adopting all of it and trying to build systems which can actually ease human life, and it's happening due to all those ML engineers and data scientists, like doing research and all, trying to implement, just like the way you guys will be doing in a short while to come. So that is how it is.
Okay. So moving ahead, I would also like to ask you, with respect to the current scenario, how AI can play an important role to help us move forward.
Oh, of course, like one of the things like that I always felt closely about is the way we study actually. I mean, sometimes I was AI can actually help us study in a better way. So sometimes doing projects, like you have projects very much like in hand when you do many projects and all. So you see, if you try to uh, address those problems using AI models, you'll realize that you can actually solve most of the problems that we have in hand. So and it can ease many of the tasks that we do. Sometimes we tend to just like the way we are doing. if you want to learn something, you have some language issues, someone has some hearing issues, someone has some medical issues, and there are always something like language translation becomes very helpful at times. Sometimes you have a you have a speech to text thing, which can actually help us like no get the transcript of the lectures, and then we can actually study it back. Those little things actually get very get very helpful at times. And as we go forward, we got to be also cautious at times. Like maybe it's helping us more and more, but sometimes there could be some problems which may not be so easily solvable. So we could actually work harder to determine as to whether a particular issue uh, is actually solvable by AI or not, and stop spending too much of time over it. And in future, we can see our the way of that we learn. Like why can't we learn the way the AI learn? So the way we learn, you can have this PDF, Adobe Reader, speaking to you in your own voice. I mean, that is something which actually might turn out to be very helpful. If someone speaks to you in your own voice, maybe something it can help you to remember things better, understand things better. So those sort of things can be actually incorporated in future course of work. I mean, it is already there, but they are trying to prune and tune the system even better and better with time. So this is unlike now, as we go on finding more and more problems, probably we'll try and solve all of these problems in future. So some may be unsolvable, we can always leave it out, but most of the issues that we have today could be easily sorted out. So future, future is very far away, I guess, and there could be so much of opportunities which we don't even know what are the things that we could actually solve in our lives. So we all got to explore together and see how far we can go with it.
Yeah, so sir, as you were also saying about mini projects, I would also like you to recommend some of our viewers that what kind of projects that they can take during their degree courses and have a
Yeah,
base for AI.
yeah. As I told you, the problems could be something which people can relate to, but to be very specific, no, I just thought since I studied boys biometry for a long time, I know where the tools and the different models are. You see, this for speech recognition, this for anything related to speech, a lot of research goes on using Kaldi toolkit. I mean, it is an open source toolkit which is written basically in C and C++. You also find some wrappers, so you could use that too. So these are the links I provide now. This is some link that I provide. This Kaldi asset or get documentation. It helps you understand how you run the code, and there are some readily available codes. Now the best thing over here is that there are some Kaldi pre-trained models. I mean, you don't actually have to understand the whole of the network, the whole of the DNN architecture over there. You have some already pre-trained models available for free. Like if you are if you intend it for research, so you can download those models. Okay, and you can download models for speech recognition. You can download models for speaker recognition. You have for LID system as well, I believe. So once you download those models and you see the codes, you can actually use some of this speaker verification model or some language identification model or the speech recognition model directly without having to actually build the model yourself. So this kind of a system will help you to develop some, even if you have a classroom, you can actually develop a speaker verification system using this kind of model. So you download it, and if you go to the toolkit, you'll find there are some simple commands that you can use to get the feature out of your speech. You can capture your speech with the help of a microphone, and then you can use that after this digital conversion. You can use it with one of the models which has been downloaded, and then you can get the features out of it, and then you can compare with the template or whatever registry that you maintain for speakers, and then you can decide as to if the speaker is a genuine or is a false speaker. You can actually think about building an attendance system for your class. I mean, given the COVID-19 situation, I mean, online attendance system, and why don't you think about it? I mean, you can go do something like that. And similarly, there are other speech recognition tool, which is, you'll find pre-trained model over it. One thing is that like it might not work that perfectly because those models have been trained with mostly with people from different regions, and it suits the people from that region alone. But it will work in other cases, but with a little lesser accuracy. So that should not be a hurdle. You can always fine tune it. So I believe like if you use these pre-trained models and and take help of this Kaldi toolkit, and you can develop some many of the mini projects like building a kind of attendance system in your class, and maybe trying to transcript your teachers whatever your teachers say, in any of your online conversation. It's already available in Google. Something you can do by yourself. Okay, maybe the Google, like you can actually think about getting a better transcription. We Indians, we have a particular accent. The Google transcript may not be able to catch it all the time. So maybe you select a kind of training data which has people which have data from people like who have a particular kind of Indian accent which we all talk in. So if you train your model using that kind of a data, probably you can do a better transcription than what Google is giving it today. So I would suggest like could explore this particular website and try and like download some of these models and see what you can do about it. There are some systems that you can build, at your home level or your school, college level or class level. So that is what I would say, Diksha.
Yeah, so that was quite a overview of many projects. And we are almost at the end of our session. So my last question to you will be, I would like you to
Come again, Diksha, come again, like I lost.
Okay. So we are almost at the end of our session, and my last question, or it's not a question, but kind of a request, to enlighten us about the Assam AI initiative.
Okay. So this is very important, like in today's context. Actually, Assam AI initiative is is an initiative taken up by a group of enthusiastic students and professionals, like who mostly are from Assam and any region. So I mean, Subrata is a very key member there, so he knows perfectly about it. So here the purpose is like to help the students from here and the professionals from here get a little exposure. We in Northeast and Assam, we always keep hearing this thing that like we lack a kind of exposure that other people from other region do. So we're just trying to close that gap where we will be able to give the students and the upcoming enthusiasts the kind of exposure and the kind of help they would require to go ahead. So it's a group of students and professionals, and these professionals as they have been working in this field for a long time. So over a period of time, they have developed skills and knowledge, and at the same time, they develop a lot of contacts. And so these contacts and these skills, which we believe will be, if we can pass on to the new generation, the new enthusiasts, it will be helpful for them, to find interest in AI in the first place, and then they can go ahead and might even think about doing some kind of projects which can be mentored basically. So this is an initiative which is actually a community service kind of stuff. So we would actually request people to join us and try and share their ideas, and if they require any kind of help in any of the areas, we'll be happy to help them. And there are people working in diverse areas, starting from image, speech. I mean, you have people studying doing research in biology, DNA, and all different sort of stuff. Probably if you contact the right person, Subrato can get you the context, so you can if you need any kind of help for your project, and time to time we'll be also having talks, seminars, and we'll be looking into it what better can be done. So in future, we'll have more and more people joining in, and all of us can actually create an environment where we can learn and explore for our betterment. So we would like to request for your support at the same time. So and we'll be happy to collaborate and learn together. So this is the whole idea about Assam AI initiative.
Yeah.
Yeah.
So this was my last question to you, sir, and also to the people watching out there. Follow Assam AI Initiative. You can find it in Facebook. They are doing a really great job. And thank you so much, sir, for such an insightful session. This was really helpful for our audience.
It was a pleasure. I mean, thank you so much to you people.
Okay, and this was the end of day 2 of DSC Explore, guys. Stay tuned to the YouTube channel of DSC Explore. We will be back again tomorrow with the final day and many other tech talks, workshops, and many more. Till then, stay tuned, stay safe. Good night.
Good
Thank you,
night.
everyone. Yeah.